Hello, I hope this finds everybody well and healthy. I would like to cover the review sheet, kind of get us caught up as to where we're at and continue moving forward. Hopefully I will do that through YouTube's and through other activities that will allow you to complete the work needed. Our first objective is to get through the CSIR 2301 Exam 2. And I want to use our review sheet, something like this is what you have right now, to actually go through and see what have we supposedly covered in class, where did we leave off, and what have we or have we not covered. I actually have taken my sheet and I have broken it up where I have some more lines in between each sheet. And so what I've done here is I have written down exactly what we have or haven't covered. So if we look at the first one, and that is number 1, it says recognize and identify by schematic symbol the PNP and NPN bipolar transistors. And you can see that I have actually done that. I have actually listed the PNP first on this one, and this is the PNP, the straight line, then the two here with the line on the other side, and this is the NPN. The way we remember to say this was pointing in permanently or not pointing in. That was one way I showed you how to remember. The objective number 2 we've covered. Identify the collector, base, and emitter for the bipolar transistors. And basically I've used the same drawings from above, and I just identified the emitter and the base for the PNP, and then you'll see that I identified the emitter base collector for the NPN. We will always know the emitter because it will have the arrow, whether it's a PNP or the NPN, and the base will always be on the opposite side. The one without the arrow that's on the same side as the emitter will show to be the collector. If we explain the basic operation of the bipolar transistors, that's number 3, you'll see that we know that it is current controlled. That again, I'll ask you again, it is current controlled. It is actually the emitter current that breaks down that junction between the depletion areas. And if you'll look, I've kind of drawn these drawings in the block diagram. I was trying to draw these earlier and record, it just didn't work. But we know the depletion area is in between these areas here, okay? And so that area right there is the area that we've got to ensure that we break that down. And the way we do that is we use that emitter base current right here. We forward bias this junction to allow this current to flow. And we do that by breaking down that depletion area. And that's the way we get that top rate. Again, I'll remind you, it is current control device. I know you've heard it at least a dozen times. Number 4, explain the basic biasing of the PNP and the NPN bipolar transistors. And if you look at that, I have drawn the PNP, tried to stay in suit. We have the positive is found on the emitter with a little bit of a negative here. And again, that would either be somewhere between 0.1 to 0.3 if it's germanium, or 0.5 to 0.7. Those are negative values. So this one right here would be negative 0.1 to negative 0.3 if it's germanium, or it would be a negative 0.5 to negative 0.7 volts if it's silicon. And this would be the most negative point. Again, we'll look at the NPN because it is the most common. We would find this would be tied to a more negative point. This would either be 0.3 to 0.7 volts more positive than the emitter, and this would be the most positive point. So this is forward biased by a little bit, by whatever the voltage drop is required for this to flow. Number 5 is where we explain the forward and reverse bias in terms of the relative polarity of voltage applied to each section of the junction. So So when we look at that, what we're going to see is that we use these above diagrams, and I'm going to the NPN to kind of explain what I'm saying. This is forward biased. This has a negative with a positive, and then this has a positive. So what we will see is that this junction here is forward biased between the emitter to the base. However, the base and the collector are reverse biased. So this would be a reverse bias junction, and this would be a forward biased. This is also forward biased, but it's more so forward biased than this one. It is this current flow that causes this current flow. So when we look at it, and we look at those diagrams, we can see the emitter base junction, and I'm trying to keep this so where you can see that, whoops, sorry, are forward biased, and the base collector are reverse biased. Okay. So number 6, we have talked about number 6. The main thing that I wanted you to know about number 6 is explain the alpha and the beta. Alpha is considered a loss and beta is a gain. The only thing we looked at was DC loss and DC gain. We just briefly have talked about this. The main thing to remember is loss and gain. We will get more in detail on that later. Number 7 says to solve simple alpha, beta, emitter value, collector values, and base values, V, I, and R calibration, or calculations, I'm sorry. Those we have covered. You've had that extensively, and I will be putting some more on. One of your assignments that I gave you was online for that. If you need more information on that, I will give it to you. But it's where we're looking at IE equals IB plus IC. We use Ohm's law. We should have done those in class. We also did the calculations on the bipolar transistors as well, where we looked at those and had that done. I am probably going to have to run this into 2 or 3 segments, and so I am going to stop here and continue on the next one, which will be number 8 next.